Hey, Topic Analyze Math Industry, and we are going to take a look at graphing circles. So we have been learning about circles in the past, and we've also been learning about formulas about circles in algebra and geometry. We do know that the area for Hey, Topic Analyze Math Industry, and we are going to take a look at graphing circles. So we've been taking a look at circles in the past. We've learned how to find the area, circumference, and how to prove them. We've also been learning about them in algebra and geometry. The area of a circle is going to be pi r squared, and that happens when you see pi. That's the first time you might see pi in an equation. And you also might get pi times diameter. That's the circumference of the circle. Or 2 pi r, which is more of a standard way to say it. But what if I told you that sometimes your math teacher might need you to graph a circle? And we probably know what a circle is, because we've probably seen how there's like this center point and there's like this round thing around it. So the question is, how do we graph it? Well, it does make sense that we will be using a graph because we are going to show pictures. But there's an actual formula that's going to help us understand how to make the circle and where the circle is going to be. So right over here is the actual formula. So it looks like we have some kind of equation. X minus a squared plus y minus k squared equals r squared. The letter H is going to represent and it's going to help you move the circle, the center point of the circle, right or left. And when I talk about the center point is literally going to be the center of the circle, which is kind of self-explanatory when I say the center point of the circle. So, if we go back, the letter H is going to tell you whatever you put in for that variable right there is going to move the circle left or right on the graph. If you take a look at the y portion, you have a letter K, and it's going to tell you to move the circle up or down, depending on what number you put in it. And the last one is the R, which represents the radius of the circle. And we do remember from like middle school math or pre-high school that the radius is going to be 1/2 of the diameter of a circle. 1/2 from the center all the way to the edge. So if this is the formula right here, then there is another formula which is the same kind of formula, but it's a little bit simplified. So right over here, if you ignore the h and the k as variables, you have x squared plus y squared equals the radius. And it's the same idea, but it's a little bit complicated. But why does the r not have a number 2 on the top as an exponent? We'll get to that when we start graphing the actual circles. So right over here are some practice problems. And one of them is in its more simplified form, and the other one is in its more original form. The thing is, we're trying to find the center point and also find the radius. Because if we can find just those two things, then it will help us put it on the actual graph. So let's get started. We have x squared plus y squared equals 16. And there's a general rule that actually makes the math very, 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 very easy. If you have an x squared and a y squared, and it's not showing like the x minus 5 and the x minus 4, then you are going to say that the point for the center point for the circle is 0, 0, or aka the origin. But what about the 16? The 16 is going to be square rooted because since the r squared is going to be in the formula right over here. We have to square root it. So 16 square root is going to be 4. So we need to create some kind of circle that has a center point at the point 0, 0 and has a radius of 4. So right over here is an empty graph. There is the origin, and we don't have to do anything with the origin because it's already the center point. But what we can do is write 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and 1, 2, 3, 4. And you would make a circle like this. I know it's not a perfect circle because I'm using like one hand, but yeah, as close as we can get. What if you try to draw a perfect circle? Type in the comments below if you can. What about the second one? The second one sounds a little bit more complicated than the last one. Well, we have an x minus 5 and a y minus 4. And yeah, it does match this kind of formula right over here. So what we can do is, you know how in translating geometric shapes we have to like move the square, then move the circle to like any part of the graph right over here? Then we can say we are going to use the opposites of what we inserted into the equation and make that our center point. So we're going to make another point, and it's going to be positive 5, comma, positive 4. That's because we take the opposites, and that is going to be the center point of the circle. But what about the radius? We have a 25. We need to square root that 25, and when we do that, we bring it to 5. So we need to create on the graph a circle that has a center point of 5, 4, and a radius of 5. So we're going to do 1, 2, 3, 4, 5. 1, 2, 3, 4. So right over here is the new center point. That black dot is still the origin. And we're going to say the radius is going to be 5. 1, 2, 3, 4. Right here, 1, 2, 3, 4, 5. Wait, this is one more digit. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. And this is going to be what the circle looks like on the graph. So that is how we understand the circle by looking at it in this kind of equation. But sometimes your math teacher might want to challenge you, and sometimes you have to do the math in circles. For example, sometimes they will actually give you the information, and you have to kind of reverse the effect and make the equation itself. So let's start over here. We have a center point of 2, 4, and we have a radius of 4. What are we going to do? Well, we do know that we have to use the opposites of what we put in. So we're going to say x. We're going to say the x is going to be subtract that by the 2 in parentheses squared. Then we have to add that by the y, subtract that by the 4 in parentheses squared. And that is going to equal, we have a radius of 4, but since we're trying to reverse the effect and build the equation instead of solving the equation and graphing it, we are going to have to square the 4. So 4 squared is 16. So this is going to be what the equation would look like when you have a center point of 2, 4, and a radius of 4. What about this one right over here? We have a center point of 3, 0, and a radius of 3. Well, what we could do is we can write x minus 3 in parentheses squared, and then y minus 0? That makes no sense. Do you remember that rule where every time you have a 0, you just use the formula above, where it's just a number or a letter and a square? So in reality, it's supposed to be x minus by 3, then we add by y squared because it's a 0 and nothing happens. And that is going to be equal to 3 squared is going to be 9. Not 3 times 3 is 9. And that is how we build the equation when we have the information. And that is also how we can visualize graphing the circles on a graph. I hope this video has helped you understand all about graphing the circles. Thank you for watching Top Opinion Lines Math Industry. Like and subscribe.